All right, today we're learning about relations and functions, chapter 2.1. Today's objectives: to analyze relations and functions, to use equations of relations and functions. Today's vocabulary: one-to-one function, on-to function, continuous relation, vertical line test, independent variable, dependent variable, and function notation. A relation is a set of ordered pairs. So any set of ordered pairs is a relation. Each ordered pair has an input variable, this is usually the x, and an output variable, this is usually the y. When there is exactly one output variable for every input variable, so for every x there's exactly one y, the relation is a function. All right, here are some of our vocabulary words. We have one-to-one function. So this one right here, this is what happens when each element of the domain pairs exactly to one element of the range. So here we see that the element 1 in the domain goes to D, 2 goes to B, and 3 goes to A. So exactly everything in the domain goes to something in the range. One-to-one function. An onto function, on the other hand, each element of the range corresponds to an element of the domain. So in this case, it doesn't have to go to a unique value in the domain in the range. So here we're going to note that both 3 and 4 both go to C in the range. This is okay. It's still a function because we don't have this crazy thing where B and D both go to 1 or something. That would make this just a relation, not a function. Then we have both one-to-one and onto. So in this case, each x has a unique y. So 1 goes to D, 2 goes to B, 3 goes to C, and 4 goes to A. So onto functions, two x's can go to one y, or one thing in the range. And then with one-to-one functions, in this case, there may be more values in the range than there are actually in the domain. All right, so example 1. State the domain and range of each relation. Oh. Then determine whether each relation is a function. If it is a function, determine if it is one-to-one, onto, both, or neither. So for number 1 here, we're going to just simply start by writing down what our x's are. So for 1, we're going to get our domain is a -6, a -5, a negative. Let's start that over again. That 9's not in there. A -3, a -1, and then a 6. Let's move that over a little bit here. We'll put a little d so we can say that's the domain. All right, so the range, on the other hand, is going to be all the y values. A -1, a -9, -7, a +7, and a -9. So then, is this a function? Well, looking at this, I'm going to scroll through all of our x's. We have -6, -5, -3, -1, and +6. Since all of those are unique, they're all different, we then have a function. Okay, so we have a function. So now the question comes down to, is this a one-to-one, onto, both, or neither? Well, let's look at our y's here. So it looks like we have two different y two different places where the y's are the same. So we have a -9 and we have a -9. We have different x's for those ones. So I'm going to go ahead and say that this is an onto. So one way to think about this is since we have two y's that are the same, it's on 2. All right, that was a little silly, but let's go ahead. Okay, number 2. All right, so in a way, for number 2, we can say that our domain is exactly what we have it here. They have it broken up for us in this t-table. So our domain is all of the x's that we see there. It's going to be a 2, a -1, a -2, a -2, and then a 2. And then our range is going to be all the y's, which is a -2, -1, 0, 1, and 2. So now we need to determine, is this a function? Trick to doing that is we need to look at our x's. Do we have any two x's that are exactly the same? In this case, yes, we do. We have these two -2's that are exactly the same. We could stop there, but we also have this 2 and this 2, which are exactly the same. So in this case, this is not a function, and we have two different reasons why. So this is just a relation. As a reminder, all functions are relations. Basically, everything is a relation, but only functions are special. We can only have unique x's in order to have a function. All right, so now we have this thing called the vertical line test. So the vertical line test is used to test a graph to see if something is a function. So to test if a graph is a function, we can draw a vertical line through the graph. If the vertical line crosses at more than one place, the graph is not a function. So an example of this is we could have, say, like this parabola. And if we were to take a vertical line and take this vertical line and cross it through, does it only touch the parabola at most one place? In this case it does, though my drawing isn't great. So this would be a function. Now, if I had, say, like a circle, could I take that same vertical line and can I get it to cross through and it touches it only one place? Well, in this case we're going to have to stop, because here and here it crosses in two different places. So this would just be a relation, whereas this would be a function. So the vertical line test will tell you if something is just a relation because it'll cross in more than one place. And if it doesn't, then it is a function. So now we have these new two vocabulary words, discrete and continuous. A relation which is a set of individual points is discrete. So a discrete function could be something along the lines of, so here's my x-axis, here's my y-axis, we have a dot here, a dot here, a dot here, a dot here. Those are all individual points. They are discrete. A graph that has a smooth curve, which includes a straight line, has an infinite amount of points and is continuous. So continuing on with this, if we had a graph and here's our x, here's our y, I guess I forgot arrows before because they do go on forever, and we have a smooth curve, something which might look like this. That curve, though it looks like a line, is actually an infinite amount of dots, kind of like the one up above. I can point to, oh, backwards, okay, like the one up above. And because all these points are infinitely close to each other that they look like a smooth line. They're actually a whole bunch of points, but they're so close that it looks like a smooth line. This is basically any line or curve. Oh, so here, let's go ahead and read this first. My face is kind of in the way. Actually, I can make my face disappear for a second here. There we go. So given the graph, is the data discrete or continuous? Does the graph represent a function or just a relation? So I'm going to start off again doing a vertical line test. Let's try to make my marker a little bit thicker here. Okay. There we go, that's a bit thicker. Now let's see. Do we cross at any x in just one place? Okay, so I can see right there I'm only going to cross one x, another one, another one, another one, another one. And as I continue on, I can see here that I'm only going to cross any x's in exactly one place. So we do know that this is actually a function. So let's answer the second question. Let me change my marker back. I think it was that one. This is a function. So the next question is it discrete or continuous? Well, we have a whole bunch of unique dots all over the place, so then this would end up being discrete. If somehow these dots were connected with a line instead, then we could say that this is continuous, but since there's no line, it's just a whole bunch of dots, that's why it is discrete. All right, let's put my face back on. All right, example 3. Graph y equals 1/2 x minus 3 and determine the domain and the range. Then determine whether the equation is a function. Is it one-to-one, onto, both, or neither? State whether it is discrete or continuous. Okay, I'm going to do that last one first. Because we're given an equation, it's going to always be continuous. I'm going to put a little asterisk there. It might not always be continuous, but in this case it will be because there's no issues where we're possibly dividing by 0. So in this case, it'll be continuous. And that's because we have this equation. We can put basically any value into this x. I can put 0. I can put 0. That should be a comma. 0.00001, something close to 0. I can put 1. I can put 1.99999, something close to 2. I can put a 2. I can put all kinds of numbers in here, and I'll get a nice, smooth, straight curve, which in this case is going to be a line. So let's go ahead and get a sticky. Make some grids here. To practice doing some graphing. So I'm going to graph 2 or 3 points here. So let's go ahead and make an XY table. All right, so it's always a good idea if you can use 0. 0 is a nice number. 0 tends to do amazing things. If I were to plug in y equals 1/2, multiply that by 0 minus 3, this just gives me y is equal to -3. But we do have that fraction. So a good trick to working with that fraction is going to be to pick numbers that are multiples of the denominator. Our denominator here is a 2. So I'm looking for multiples of 2. Well, 1 could be a positive 2, and to keep things simple, a -2. Now we just plug those in. All right, I'm going to get rid of these numbers over here on the side. Those were just an example. You can always go back and rewind. So plugging in -2, I'm going to get y equals 1/2 times 2, -2, which is actually a -2 over 1, minus 3. Here the 2 and the 2 will cancel. We still have that negative, so we have to be careful there. And we get y is equal to -1 minus 3, or y is equal to -4. Because it's always good to plug in 3 points, because we never know if we made a mistake on one of them, but when we're doing this, which is a line, if we have 3 points, we'll very easily see that one of them was a mistake. Let's go ahead and just do a third one. So we're going to get y is equal to 1/2 times 2 over 1 minus 3. Here these 2's cancel out, and we get y is equal to 1 minus 3, or y is equal to -2. All right, so right away I can see that I made a mistake. Take a look at this. This was a -3. I wrote just a 3. So right there, had I only had 2 points, I would have seen that I had a mistake because I was making a triangle, not a line. All right, so I see my y's are all in the negative quadrants. So what I'm going to do is I'm going to make my graph, kind of looking ahead here. And I'm going to see, since my y's are negative, I'm going to go ahead and put them so that there was more negatives than positives here. Let's make this a little bit thicker so that way our viewers can see it easier. Now I'm going to take my points. So each of these, -2, -4, are 1 point. There's 2 coordinates, but there's 1 point. So I'm going to do -2 in the x. So I'm going to go backwards 2. And I'm going to go -4 in the y. And then where those two things cross, I'm going to get my first point. Now I'm going to do 0 in the x, and I'm going to go -3 in the y, and that's where I'm going to get my second point. Now I'm going to go 2 in the x, and I'm going to go -2 in the y, and I'll get my third point. And lo and behold, I've got 3 dots that are lined up. Let's see if I can make a straight line. That works. A little bit off, but that works. All right, last example. Here we go. Given f of x is equal to 2x squared minus 8, find each value. So what's happening here is they're giving us a direction. The direction is saying take your x's, in this first case it would be a 6, because that's supposed to be an x, and plug it into your x's here. So for a, I'm going to get a 2 times 6 squared minus 8, which then gives me a 2 times 36. Keep in mind your order of operations, parentheses, exponents, then multiplication, division, then addition, subtraction. So I'm going to get, let's see, 2 times 36, that gives me a 72 minus 8. And no, I'm not afraid of, okay, that gives me a 66. So this tells me that my f of 6 is equal to 66. And I probably should be better and do the same thing up here, saying that the f of 6 is equal to that. And then I can just do kind of these streaming equal signs all the way down. And that kind of shows all the work. I don't need to write the f of 6 every single time because we're going to assume what's on the left above it is what stays. All right, b, on the other hand, gets a little bit more complicated. B, we're not replacing our x with a number. We're replacing our x with a number and a letter. So a good step is, which you may have seen me do on A, is when you replace your variable with something, replace it with parentheses. So I'm going to get 2 parentheses 2y squared minus 8. So that's going to give me a 2. I'm going to keep the parentheses for now because I'm going to be doing the exponent. 4y squared. So I squared the 2, which gave me a 4. I squared the y, which gave me a y squared. And let's not forget our minus 8. Now I can do my parentheses. I can do 2 times 4, which gives me an 8y squared minus 8. And that is what I get for f of 2y. All right, that was today's lesson. Next, we have nothing.